It looks like it's just. Oh no, it's just me and Gabe. So another option is that we could record our screens and then record the audio from the microphone, post later, like worst case. I've done that before and the quality is pretty good. We'll try this. I'll DM you the share link in Twitter. Sorry? I'll DM you the share link in Twitter. Okay. Okay, it seems to be in it now. I'm going to meet up with RxJS.
Yeah, because now the audio is coming from my side.
I think that's yours.
Let's go stuff.
Oh, yeah, sorry.
All right, test.
I don't know. Higher? 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 How's that?
It's shit. But okay. All right, now we're back. We're back live. I'm gonna have to retweet a new live link, I think, but that should work. All right, Mulligan. We're gonna take two, and this time it's gonna be even better. Okay.
Okay. Wait. Everyone hear me? No? Yes?
Not really.
Not really.
I'll hold the mic for you. It's just. Sorry?
Is that jacked up? Yeah, it's on. It's on. But
But if you have to hold it anyway. Yeah, just clip it. Clip it on the beard. Beard's not long enough.
doesn't work. Doesn't work. Okay.
Plus, this is crackling. You may as well use this, and I'll just hold your mic while you type. Okay.
All right. Okay. Take two. Hey everybody. So my name is Gabe Scholtz. I'm coming from Vancouver. I work at Brewhouse Software. Hooray! Thanks for having me here today. I'm going to be talking about building data flows in your JavaScript applications using the observer pattern and RxJS. Has anyone heard of RxJS? Maybe. I got all the questions. So RxJS is an implementation of the observer pattern, and so that's what we'll be talking about. Some cool links down there if you want to check those out, but I'll deploy this thing later. It's a web app. Okay, so the agenda for today is that we're going to be talking about what is reactive programming, and then what are observables, and how do they work to implement reactive programming in JavaScript. And then how can we use observables to build more cohesive data flows in our applications? It's much smoother this time, isn't it? It's like I've done it once. So Wikipedia defines reactive programming as a paradigm oriented around data flows and the propagation of change. And so what does that mean? Here we have a little bit of a code example. So up top, we just have this page div that gets rendered into the document. And then we have a function called render user page, which takes some state and renders some template. And that state here is our user. So here we have a user, first name Brent, last name Vatne, nickname Rick. And then we pass that into render user page, and when we run that code, we get this output on the right-hand side. So first name, last name, nickname. But if we change this, naturally, if we run the code again, the first name does not get updated. And that's because we need to call render again. So every time we change our data, it is sort of implied that we have to also call render. And obviously, JavaScript doesn't do this for us automatically. And it's fine at first to have to call render again when we update our data. This is something that we did 3 or 4 years ago, or we still do today. And that's fine for like a small little template. But when you get to anything larger, say you have multiple templates, or you're no longer using that base set of data that you're updating, you're now using derived data, it gets a little bit more complicated. So here I've changed my template so that it depends on a full name rather than a first name and last name. And so that means that we need to calculate that value before we call render. So that's what we do here. But if I update my first name and I call run again, again, that doesn't work. And actually, even if I call my render function and I forget to update my full name, you can see that the first name of the person here does not change. This is a problem. It can lead to bugs because there is an implied dependency on full name from the user's first name. And then following from that, all of the templates rely on full names. So when we update the first name, there is a indirect dependency on the template from the first name, right? We have to recalculate the full name because it depends on the first name, and then we have to re-render our application. So we have this dependency chain that gets built up. React is really good at this because in React you call set state, and then the entire subtree of your application gets re-rendered again. Now, this isn't real code. This is just for speaking purposes. But here it's more useful for us to think of our data as each of these values, to think of them as a source of data rather than a single value themselves. So the full name depends on the first name and the last name. User page depends on full name, and the app depends on the page. So if the first name changes, then all of those things need to change as well. So there's this cascading update that needs to happen, and so we get this data flow that propagates through our application. So just like React can reactively update your templates, RxJS will help you reactively update these sources of data that you have in your application. So before we start talking about Rx, I'll just, again, demo sort of what I did here. On the left-hand side, we have this code that I will edit at some point when Eric decides to hold the mic for me. And, yep, cool, not yet. And then on the right-hand side, we have an iframe that all of the code gets rendered into. And then at the top, we have this time graph. And I've monkey patched console log so that the first value of the log is the name of the stream that we create, or the name of the axis that we have. And then the second value is the value that gets printed. So if I run this code, you can see that here we have the name. So here we have stream, which matches this one. And here we have interval, which matches this one. And of course, I've wrapped this in a set interval, so I'm going to log this out every 2 seconds. And so what this is meant to illustrate is just that, as we'll see later on, this will make understanding how these data flows get composed in our applications a little bit easier, because we can visualize them. Okay, so when we're talking about observables, I like to do it in the context of a promise. So a promise has, this is how I like to start, because a promise has a very similar abstraction, and a lot of people have used promises at this point. So right, so with a promise, right, you create a new promise. The argument that you get is a function, and then what the promise does is it wraps a single asynchronous operation. So in this case, we're just calling resolve immediately, and we pass in the value world. And then, so if we run this code, we get hello over here, because that's the name of the stream again, and it prints out world on our little bubble. But no matter how many times oh wait, no, never, that's for another point. So an observable is very similar. RxJS, you would say rx.observable.create, and then you give it a function. And instead of passing in a function as an argument, what Rx passes in is an observer. And this observer has 3 functions on it. One is next, one is complete, and one is error. So if I call the error function, then it will error. If I call next, what it will do is it will pass a value to anyone subscribing to it. And if I call complete, it will kill the observable. So if we run this, we get the exact same thing that we got with the promise. So lesson number 1, very similar abstraction. And here they are side by side. So here we have the observable being resolved and the promise being resolved. And they get resolved at the same time. So lesson number 2 is that observables are sort of not like promises. And the first way that they're not like promises is that they can resolve many values. So here what I have is I have an observable set up where I pass the value next to it. So that will pass the string first to all of its subscribers. Then 1 second later, I'll pass the string second to all of its subscribers. And then after another second, I'll pass the string third to all the subscribers. And then after another second, I'll complete the observable. I'll kill it off. The promise will do the same thing. But with promises, there's no need to call complete, so we'll just pass first, then second, then third. So we'll see what happens here. When I run this, the promise can only ever resolve 1 value at a time. Observable can resolve as many values as we like. So in this way, observable sort of becomes a stream of values. And so when we subscribe to an observable, we can anticipate that we're going to receive multiple values over time. So in the next way that observables are not like promises is that they are really lazy. So unlike a promise, so if I run this code, you can see that the promise resolves immediately. Yet It does not. So we have this log in here, and notice that the promise itself does not actually have anything subscribing to it. We just create a new promise, and then the promise immediately calls this function and evaluates whatever happens. So let's say you had an AJAX call. Even if I don't subscribe to that promise, that AJAX call will get made anyway, and then I guess we would do nothing with the result because no one subscribed to it. An observable will not do anything unless we're subscribed, so I actually have to uncomment this code here so that we're subscribed to the observable, and if we do this, then you can see that they both get resolved. And actually, what did I do? Oh, a typo here. So we'll say sub here. Right, so this code block gets executed and ends up logging this out, and then this console log gets called. Pretty much the same thing, at the same time. So next is that observables are also cancelable. So we can cancel them in both inside the observable and outside of the observable. So let's see how that works. If we run this code, after 1 second, so both of these observables have a timeout inside of them, so it's sort of an asynchronous action. And the observable here calls on next, and then it completes. And again, on complete is a way for the observable to cancel itself or kill itself off. So if I move this here and I run this code again, you can see that after the second, the observable does not emit another value. So after the observable has been canceled or it's been completed, we can no longer pass values to the subscribers of that observable. And so that's how we would cancel the observable from inside of it. Additionally, whenever you subscribe to an observable, like we're doing here, we get this subscription object back. And the subscription object has a method on it called unsubscribe. And if you call that function, then it will cancel the observable. So this just makes it really easy for us to create an observable in, like, say we have some function that we call and it returns an observable, or even it returns a subscription. Yeah. So if I don't subscribe to it? No. Yeah. Yeah. So we can call observer.next at any point that we want. So if we had, say we called jQuery Ajax or something, right? In that success callback from inside of there we can call observer.next and then pass the value that we resolved, and then it will go to any external subscriber that the observable has. There's some subtlety there, but I won't. Yeah. Okay. So here, what I'll do is I'll take this subscription and I'll call unsubscribe on it, and we'll do that before this timeout is able to complete, right? And so if we run this, you can see that we created a log here. So the subscription gets created, but the observable itself never actually resolves anything. And then finally, if we quickly undo that, an observable can also pass a callback. So there's a return value that you can give it, which is a function, and that function will get called when the observable gets completed. So in this case, when this gets called, this function will get called for us. Or if this gets called, then this function will get called for us. And this is useful in cases where, say, you set up, you hook up an event handler inside of this observable. If you hook up an event handler, you probably want to unhook it when you're done with it. You don't just want to leave it, because that's a really bad memory leak. So here, you can see that the observable resolves, and then the callback gets fired. Okay, so next, how am I doing for time? No. You could just not call on next. Once you cancel it, you could create a new observable. Maybe we could talk about it after. We could program it after. Would be awesome. Yeah. It will. So here's that subtlety that I didn't really want to get into. Good question. Whenever you subscribe to, so this is what's called a cold observable, and whenever you subscribe to the cold observable, it will call this function again, and it will set up a brand new observable. Yes. Unless you do something to make it hot. Then yeah. Yeah, it's just hot, cold. Forget about it. Yeah. So lesson 3 is that observables are sort of like arrays, in that they have these combinators that you can apply to them in order to transform values. So here we have an array, right, with the numbers 1 to 10. If I run this code and I log everything out, I get this result. I filter out everything that's not even. I then multiply by 3, and then I log it out. So if I run it again, we get this, what we would expect to see. Observables are very much the same. So here we have this observable that we call all the same things on it, and here I'm doing this deliberately. There are shortcuts for this, but here I'm passing in those values one at a time to that next function. And if I call run, I get the exact same output. And so in a way, you can sort of think of an observable as if it is an asynchronous array. So these combinators, or the functions, whatever you want to call them, they get applied to values as they come in. So can you hold this one second? So if I say take these last 2 functions and I wrap them in a set timeout, or this last 2 calls. Thank you. And I wrap them in a set timeouts where I wait a second until I pass in the next 2 values, right? That last value comes in 1 second later, and that's because it's sort of like an array, right? But we're only going to apply these operations to values as they come in. Not sure if that, yeah. Okay, and then finally, they're sort of like an array because they're composable. So here, what I've done is I have this observable, and I'm calling it fast. It's a fast counter. So every second, we pass a new value into the observable, and then we increment the counter. So first we pass in 0, and then increment it, and then every second after that we pass an extra value. So this is sort of what it looks like. So every second gets a new value, and we pass it on to our subscribers. And then I got this other one. Crap. Is that it? No, that's not it. There we go. So I got this other one called slow. And slow is going to do something similar, but it's going to do it much slower. And it's going to increment values at the same, or at increments of 5. And then what I'm going to do is I'm going to create this other counter, and I'm going to call it total. And then I'm going to apply this operation called combine latest. So combine latest is going to take the fast observable, and it's going to take the slow observable, and it's going to take a function. And anytime either of these receives a new value, fast will call this function and evaluate itself to have a new value. So, or total will, sorry. So that's sort of what that looks like here. And what's really important to notice is that by doing this, I now have these values, but they're not really values. They're sources of values, like I talked about in the first few slides. And this, what I've highlighted here, this A plus B, this is a relationship between these 2 streams of values. So fast and slow, I'm adding them together, right? Total is just a relationship between these 2, and anytime either of these receives a new value, total is automatically updated. So if I change this to multiplication, we get a completely different result, but that's because we've completely changed the relationship between these 2 values. Right? So now it's all about multiplication party going on in here. Go to the next slide again. So So, and then the final lesson is that all async in your JavaScript applications can be represented as an observable. That means Ajax calls, WebSockets, event handlers, even plain values, right? We can wrap it in a set timeout, or we could just not. We could just call not next immediately and then complete the observable, and then that's an observable, but it's a sync value. So here, what I've done is I've created a button. I set some inner HTML, and then I append that to the body, and then I wrap the button, the event handler. So I'm going to listen for click events, and I'm going to ask it to use this click handler where every time I receive an event, I just call next on that observer where I pass that event in. So that means that when I set up this subscriber, so clicks here, clicks is the complete series or time series of clicks that happen on that button. And so if I run this code and I click, then I pass that event in, and then we get a new value. So I can totally hammer on this, and it keeps resolving. But the idea here is that the clicks is of that action that I'm taking. And there's a shorthand for this, which I'm going to use in the next slide. So you can say Rx observable from event. You pass it the element and then the event that you want to listen for. Okay, so we can get this we can make this a little bit more complicated and use all of these combinations and stuff that I was talking about. So if we run this code, here we have two buttons. One is a +1 and one is a -1. This currently doesn't do anything. If I let's uncomment the plus and then subscribe to the plus. So we're going to create an event handler for plus. We're going to listen for click events, and then we're going to map those click events to the number 1. That's all we're going to do. So every event that comes in, doesn't matter when the click happens or where I click on the button. Like, we don't care about the event. We're just going to map it to a 1, and then we're going to print that out in the log to +1s. So if I run this code again and then I click plus, right, we get basically the same thing that we got in the last slide. I'll do the same thing for minus, or I'll subscribe to it. So if I run this, so I get now a stream of +1s and a stream of -1s. And now what I can do is I can call another command, which is called merge. And that's a little bit different from combine latest. So combine latest will wait for a new value to come in from either of the streams and then combine them together with a function. Merge just says, it's like two streams, like two rivers merging together, right? All the water is now part of one giant river. So if I run this code and I click +1 and then I click -1, you can see I have this new stream in the middle that is just a stream of 1s and -1s over time. So if I click the 1, it will inject a new value into the 1s, and if I click a -1, it'll inject a -1 in there. It'll pass a -1 down this stream. And then finally, I can then keep a count of these 1s by calling this thing scan, which is a incremental reduce, meaning that, so this function here is a reducer, and here the accessor is the previous total, and then I here is the next value that gets passed in. So we're going to start with 0, and then when I'll just show you. It's probably easier. I got this. I set up this whole thing. I spent weeks on this. Okay, so we start with 0, right? So the count observable emits 0 immediately. If I press +1, count is now 1. If I press +1 again, it's now 2, 3, 4, 5. If I go -1, it will decrement the count. Right? So now count, in a sort of abstract sense, is the total at any point in time. It's the total of all of the clicks that we've counted, and we don't have any. I mean, aside from like this stuff here, there's not really any imperative code here, and there's not really any setting of variables going on, right? Count depends on how many times we click the plus button, and it depends on how many times we click the minus button, but we're not actually setting any variables here. We have hard dependencies between the +1s and the -1s and they end up creating this count variable. And there's like no side effects. We don't fire off an event handler or anything. There's a very clear data flow and chain of dependency in this like little mini application thing. Cool. And then you can use it for some like next level stuff that it just totally gets out of hand. So here I have a div. And when I drag my mouse around in the div changes color. And all of that behavior, all of it, is implemented by like a few lines of code. And so what we do is we take that div, which I just called block, and I'm going to listen for the mouse down events, the mouse up events, or the mouse move events, and then the mouse up events. And every time there's a mouse down event, I'm going to call this thing called flat map. And so what flat map does is it takes that previous stream, and when the flat map is going to return a new stream or a new observable, and it's going to replace it with whatever that observable gives, and it's going to pass that down the stream. So what that means is, if I can try and elaborate, whenever a mouse down event is received, we're going to listen for all of the mouse move events, and we're going to take all of them until we receive a mouse up event. And so that's why when I move my mouse here, and then I let go on the click, when I keep moving it, like nothing will happen. So only when I mouse down does it track the mouse move events, and then when I mouse up, it will stop listening to them. Right? And so like I give it this really long name, but this is probably a representation of what this is actually doing. And it's a very declarative operation. So mouse moves while holding mouse down. Yeah. Can you hold this for a second? Thanks. So if we take the mouse down events and we just go like console log move, let's do one. There we go. Okay, so here we'll take the mouse down, we'll subscribe to mouse down, mouse up, and mouse moves while holding mouse down. Thank you. Oh, I have a syntax error. Forgetting that should do it. Perfect. Okay, so when oh wait, sorry. Oh yeah, no, it's right. So this is actually down, up, and then like move. So if I graph this out, when I mouse down, I have an event, and when I mouse up, I get another event. But you can see that like I move the mouse and I create all of these events, and then I mouse up, and now my computer's frozen, and then we get the event. So yeah, you can kind of see what's happening here. I guess this is a much better visualization of how this event stream is working. Cool. Right, and then so how am I doing for time? I'm pretty close. Okay, I had some other stuff. We'll just cut it off here. This is I've told some people really like this example. They find it really compelling. So because this is running on a web server, I've set up this endpoint called days, and when I run this code, I get back an array which is the list of days in the week. And so Rx has this extension called Ajax Observable where you can create you just on a string, and it'll make a request for it and then return an observable. And when that request resolves, it will pass the values along to the subscriber and then end the observable. But that's not really that great. What we could do, I left some stuff in here. Let's get that out of here. So the day endpoint actually accepts a search operation. So what I can do is I can, on my, I've created this input here, and I've just appended it to the page. And so when I type a key, what happens is an Ajax request is made to the server. It filters out the days that don't match that query, and then returns the final array of So here we're taking that search value. We're taking basically what we're doing is we're going when this input, when there's a key up event, I'm going to take the current value of the input, and I'm going to flat map it. I'm going to replace it with a different observable, which is now an AJAX call. So what we're doing in essence is mapping key presses to AJAX requests, which is pretty cool. Yes, cool. And if we look at part of this, there's a little bit of a problem here because if we added a little bit of a delay, so this endpoint also accepts the delay argument, and delay equals. So if we add a delay, it's a random delay for a second. We got to run it again. So every time I have a keystroke, like obviously I don't want to do it every time I do a key press. Maybe I want to have a little bit of a debounce. So we can add a debounce. So we'll go maybe a quarter of a second. So you say debounce time, and then as I type, nothing happens, and then a quarter of a second later, it'll wait until I'm done typing. So I can do like third, and then it will resolve. That's if there's a delay, but there's a bit of a problem here because if maybe we can get it. You'll notice there, I typed in TH, and I ended up with everything that had the complete list. And that's because when we call flat map, what we're doing is we're taking all key presses and we're mapping them to new observables. So we do this. So what we really want is we want to do a switch map, which will discard an observable. So every time I do a key press here, it will create a new observable. So I'll make this AJAX request. But what I actually want to do is if I type another key, I want to discard the previous request because I no longer care about the previous request. If I type T and then I type THRS, right? You see that a bunch of these requests actually get aborted and they get canceled because as I'm typing, I don't want to accidentally return the result from T because it's the server, and the server, like there's latency involved, and so the request that I made when I typed T might actually come back last, in which case I just get a bunch of results and then I have bugs in my code. So if we call a switch map, we'll actually discard this. So. And it can also be further mitigated by this. I don't really have time. Do I have time? I'm done. I'll just send it. Yeah. You sure? Okay. I also added a fail command here, which fails a certain percentage of the time. So if we say that we want to fail 70% of the time, it should. No, that didn't fail. There. Okay. So we get an error. Failed. Shucks. What are we going to do about that? What we can actually do is we can, Rx comes with this really cool function called retry, and you can give it an argument. So I can say if I want 5, and then this will probably fail. Let's see, M. Is that going to even do it? Did I run the code again? M. So the first one failed, but then the second one succeeded. So you can actually restart an observable after it's failed. And this really helps if, and we use RxJS on our servers, talking to databases. If the database goes down for, a fraction of a second, you don't want to have a failed request. You'd just much rather that it retries the request, right? And then returns the result after you're done. So RxJS does that pretty seamlessly. And yeah, I guess I'll just end it there. I have a few more slides, but I've been talking for way too long. So chat stuff, conclusions, observables are awesome. That's pretty much it. Cool, and thanks. And then those are the slides or resources.
All right. Big round of applause for Gabe. That was sweet. Sorry, doing a dance. I think we'll take a really quick break in case people need to hit the washroom, take off, whatever. and then we're gonna get Brent up real quick on the mic. So maybe just 5 minutes, real quick washroom break, and then we'll get going again.
How long was that exactly? Yeah.
All right, all right, all right. Okay, let's get this second session underway, and then we can keep chatting, drinking, whatever until later. These guys have to fly out tomorrow morning, so I don't want to keep them too much longer than they need to. Okay, so without further ado, we got Brent Vatne on the mic, and he's going to talk about some stuff about React Native. And I'm going to let him just have at her.
Hello. Okay, good. Right. So can I just get a show of hands? How many people use React at work or on a hobby project or anything? Okay. Yeah, that's great. Okay. So that's a decent amount of people. But I still think it's relevant then to ask the question, even before we talk about React Native, why React, right? I actually don't really care if people use React. It doesn't matter to me at all. But like it could matter to you. So why React? And the answer to that, because it's 2016, right? Come on, guys. Come on. No. I don't know how popular that's going to be here. But I think this was like the only riding that voted liberal, like Central Calgary. So I'm safe. Yeah. So I mean, there are already so many articles and presentations that talk about like why you should use React, explain the benefits of it in a very clear way, and I would probably just be wasting everybody's time to repeat that. But I think it's worth sharing maybe a lens that I like to use to evaluate different technologies, and that is, you can sort of ask yourself, what jobs does this tool or technology make easy, and what does it make hard? So, I mean, when we think about React, with JavaScript, any programming language that is Turing complete is capable of solving any problem given sufficient time and memory, I believe is the definition of it, right? So, so really, what differentiates one language from another is, right, what it makes easy and what it makes hard. So we can kind of think of JavaScript frameworks, I think, in the same way. So all of them help you to build a user interface, but some of them make certain jobs a lot easier than others. So for example, with jQuery, removing an element from the DOM is really easy. But with React, it's not so clear, or at least it hasn't been until recently, how you can unmount a component and animate it at the same time without being very verbose about it. So that's just something to keep in mind. So I think there are some very good arguments for using React on the web, even if React Native doesn't matter to you at all. I personally think it's the best tool that we have for building complex user interfaces right now. And what React Native does is it makes another thing easy, which is to take your existing skill set and use it on other platforms. So currently, that's iOS and Android with React Native. There's definitely another one coming soon. Yeah, but like, what parts of building a native app with React Native are easy, and what parts are hard? Because there's also, you have to consider that as well. I mean, using React Native versus using like Cordova or using whatever native tool, there's going to be trade-offs to those. So we're going to talk about some of those things and hopefully just answer a lot of common questions that people have about React Native. So that's why I'm calling this discussion sort of React Native for prudent, risk-averse, or just skeptical people. How many people have used React Native? Yeah. Okay, good. That's sort of what I thought. Yeah. So what I did in preparation was I went on Twitter and asked people, like, what are some concerns that they have about React Native? Oh, okay, good. And there were like quite a few replies, and so I took a bunch of those and I put them in here. I ignored a bunch of those. I answered a bunch of those, and then I put some of mine in here too. And yeah, so here we go. Part 1, why should I care about React Native? I'll skip that part. Okay, so I think there's sort of like a few groups of people that are kind of thinking about React Native and considering whether they should use it or not. So the first group of people is probably people who have felt like they've been misled by other technologies in the past. So maybe they've used Cordova and it didn't quite do what was promised, and they thought that they would be able to make this great app, and then it turned out to be really awful. We've lost the projector. That's okay. It's the same thing on there. I'll keep going when I figure that out. That's fine. Right. So there are a lot of tools like that. I'm not singling out Cordova that like promise code sharing across platforms. You can use one language and write your iOS, Android, Windows Phone, BlackBerry apps in whatever language they choose. Yeah, so a lot of people have been burnt by this. They've maybe made commitments to build apps and they haven't been able to deliver on those to a level of quality that they're really happy with. So I think that's kind of the first group of people that look at React Native. The second would be people that are maybe happy with the cross-platform tool they're using already. So maybe like there are some good ones, right? If you use Xamarin, lots of companies use Xamarin pretty well. Sure, it has its problems, like everything does, but I think a lot of people use it like pretty effectively. So maybe they use it, they like it, and they're just wondering what else is out there, and maybe is this other thing better. The third would be people who already know how to make native apps. So cut out. They might they might be asking something like like isn't this just a way for people who don't know how to make native apps to make native apps, or like native apps, or like, you know, or they just might be like, oh, you're taking my job, something like that. They're definitely doing that. Lots of them are doing that. And then the fourth is probably most people here, web developers who have never really tried mobile development before. Or maybe you've made a responsive website and maybe like dabbled briefly in things, but never like made a legitimate sort of go at building an app and shipping it to the App Store and that kind of thing. So I'm hoping that what follows will sort of convince you that React Native, I think, is pretty innovative, and it's also a practical new technology that you can start using, and hopefully in your next mobile project. Oh, we don't have slides yet. I can just read this part out still. Oh God, this is dangerous. Is the power light supposed to be flashing like that? Is that standby? It's standby. Technical difficulties. Well, all right, it doesn't matter so much for this particular slide, I guess. The next one would be good. Oh, is that, I think that's the problem? Actually, it would be pretty useful for the next one to have it like within. Oh, it's still showing up with the others. Yeah, it's still showing up. It should be this one. It should be screen 2. Let's wait for that because it's still. Sorry, this will take another minute or so. Oh, it looks like a. Yeah. That's okay. Well, while we're waiting, why don't people just like ask me questions about React Native that maybe I will answer anyways in the presentation, but like we might as well just do that. So yeah, put your question.
So when you're coding in React and you're going from iOS to Android, what's the major differences, if any?
So if you're just using the sort of primitive view components, so like views and text, that sort of thing, and just basic styling, you're not going to run into any significant differences. That said, there are a few platform differences. For example, on Android, the views have overflow hidden by default, and it actually can't be disabled at the moment. So probably the best for like this platform component development is just to have everything as overflow hidden, so it'll just work on iOS and Android in the same way, like that. And that's just the limitation of the Android view system and how that works. Aside from that, like you might have to be aware if you're using platform-specific components that maybe don't exist on the other platform. I think at this point, most of them do. Maybe someone can correct me if they know, but oh, we have stuff. Nice. All right. Good job. Oh, yeah, right, sure. Screen 2. Okay. Good. So one common question is like, so are also powered by JavaScript, and they don't feel like apps. So why would React Native be any different? So this is like not the easiest thing to answer, but let's have a quick look at some of the reasons. So what we're looking at here are the platform components for, on the left side, that's in the browser. So those are like the built-in DOM components, like text input, select, et cetera, et cetera. In the middle, that's on iOS. And so we have like a map view, we have like loading indicators, things like that. And you can kind of think of these things as like, these are primitives that exist on these different platforms. And so React on the web uses the platform primitives that you're given, right? You're given like a text input and paragraphs and divs and all of that. You don't have those on iOS and Android unless you use a web view, which we're not. And so what you instead use is the platform-specific components that you are given on that operating system. So it's really not that big of a conceptual leap to think, okay, well, we can use this JavaScript tool to update this interface with an imperative API, and just take that and change the API that it uses to update that interface so that it works with whatever other platform. And so that's basically what React Native does. And so if you compare that to WebView-based frameworks, what you essentially get is you take the window on the left there, and you're kind of just shoving that inside of an app on iOS or Android. So that is one significant difference. Another one is the threading model. So to quote Andy Street, who is a guy that works on React Native Android at Facebook, he says that the threading model fundamentally makes it difficult to not be performant, or rather hard not to be performant, when interacting with native platform components. So I'm going to jump back here in a second, but first I want to show you this example I recorded a while ago. So at the bottom, I just have a for loop that's going from 0 to, I don't know, like 1 billion or something like that, and adding that number to a string. So there are better ways to simulate blocking the JavaScript thread. This is just the first one that came to mind. So what I'm doing is I run that, and then I go to the page, and I try and scroll, and I try and hover on things, and nothing happens. You'll notice that. So here I'm scrolling, right? And I press enter, and I go back. I'm trying to scroll. I'm trying to hover, It's not working. And so the reason for this is that in the browser, the JavaScript runs on the same thread as the thread that processes user input and also handles scrolling and that sort of thing. And so it cannot, while the JavaScript is executing before it yields control, it can't process any user input. So that is definitely a downside of the browser. So if you compare that to React Native or native apps in general, because they usually take better advantage of threading, the JavaScript engine actually runs on a separate thread from the UI thread. Layout is calculated on a separate thread. Images are decoded on a thread pool. And they're usually each native module has at least one thread. And so what happens is that even if this thread is executing, it won't actually block any of these other things from updating in the interface, and most importantly, from processing user input. So I've lost my mouse. Okay. So right. So in this video, what's happening is that press the button in the top right, and that is doing the same sort of thing that I did in the previous example. But you'll notice, see how it remains pressed, and I'm still able to scroll. And then finally, when it's done processing, it does the result of that action. And so that's because we have this JavaScript thread. It's just like sitting there doing a bunch of adding a number to a string, and the UI thread just doesn't care. We have a bunch of cores on our phones. We might as well be using them, right? So this is, like I was saying, images are also decoded on the UI thread in the browser. That's a big problem. You've probably noticed that when you're scrolling down websites that have like pretty heavy images, it'll just like drop a few frames. And so by drop a few frames, I mean like you're supposed to be going at like 60 frames per second. And so it will just not show updates on the screen for a few of those frames. Right. So going back here, I just want to define quickly what I mean by performant. So you can kind of consider performance in user interfaces as how responsive they are. So like how quickly do they respond to your input? So you want to keep that below 100 milliseconds. Otherwise, your app will start to feel kind of laggy. And then the other one is smoothness. So you want to be staying as close as you can to 60 frames per second. And if you have to make a trade-off at some point, it's a lot better to do things like in video games, they often lower the frame rate on mobile devices to 30 frames per second because you want to be consistent rather than, say, be going at 60 frames per second, drop 30 frames, which would mean you don't update the screen at all for half a second, and then resume. Okay. So, so you might be thinking then, like, well, you know what? I heard threads are pretty confusing, and like that's sort of why I do JavaScript. I don't, if I wanted to do threading, I would just write a native app or whatever. So isn't this going to be really hard? Well, actually, unless you're writing native code, the only impact that this will have on you is that certain operations that in the browser are synchronous will be asynchronous. So let's have a look at what that sort of manifests itself as. This might be hard to read. I tried to make it big. Hopefully that's good. So the first example, what I'm doing is I'm calling this function called measure on an element, let's say, and then I'm taking the X and Y position and the width, etc., and using that to update some state on the component. So if you look at the bottom example, what I'm doing is just finding this DOM node and then calling offset width on it to get that property from it. So comparing those two, you see that you have to actually pass in a callback to get this value when it's asynchronous, and you can actually synchronously get the value off of it when it is synchronous. So React Native is also built in with most of these native modules provide, or rather they'll return promises. And so you can use async await, which if you're not familiar with it, don't worry too much, but definitely you should check it out later. It just allows you to write code like in the second example, which looks like it's synchronous code. So yeah, that going back here, that's sort of the main cost that you pay for that is that the communication is asynchronous. So you probably can't really see this, but what's happening here is I'm logging out all of the actions, sort of these commands that are sent over to the native side, and likewise the commands that are sent from the native side to the JavaScript side. And so the way that this asynchronous communication works is that you have something called a bridge in between these two runtimes, let's say, and they add messages, add commands to a queue, and then on every frame they will flush that queue, run those commands, and then the resulting on native will take the result of whatever was done there. So maybe you I don't know, like set a timer and the timer expired, then it will add the call this timer callback to the queue and then run that on the JavaScript side. Don't worry too much about the details of that. It's actually really cool that you can just go into React Native and modify the message queue file and turn on spy mode and just watch as all this stuff happens. So you could see like one of those is receive touches. So when you touch the screen, that is received by the native runtime. It's then turned into this event that is put into the queue, which is then emitted in the JavaScript runtime. But yeah, don't worry too much about that. This is the main thing you need to consider there. So I get this one too. It's like, oh, but I tried it and it sucks, or it's like slow. I mean, like it's not going to do everything for you, right? It's like you can make, yeah. Well, I didn't want to say that, so he said that, but no, actually, it is easy to make apps that are like slow with React Native. Just like with actual native apps, it's very easy to make things that are slow. It's just sort of the nature of how it works on these devices, where you are demanding. You have very high demands on what the user interface can do, and also limited resources. Yeah. So one of the common causes of apps feeling slow right now is that animations are run on the JavaScript thread. So what I mean by that is that on every frame, the JavaScript thread has to say the exposition of this view is now 200. And then the next frame, okay, now it's 201. Now it's 202. So if you do something that on the JavaScript thread takes 50 milliseconds to execute before yielding control, then what will happen is that your animation won't be able to send over its update until after that is completed. And so you'll drop a few frames on that. So this is actually like kind of a solved problem. It's a work in progress, but I'll talk about that a bit more later. Yeah, so what React Native makes really easy right now is keeping the UI thread responsive while you're doing sort of your application logic on the React thread. It takes work still, but React Native is being designed with the principle of helping you fall into the pit of success. So the goal is sort of that you will use this and you will accidentally just do the right thing. And yeah, so with animations, what's being done there is just, you won't even notice. You'll just do an update and then you'll be like, wow, my app is a lot faster. So yeah, there's way more to be said about that, but there's no time for that. So another question is like, okay, sure, so it feels better than the DOM. Like, oh, good job. And so is it actually going to be like as good as this native compiled code that, you know, is like Objective-C, compiles down to machine code, whatever? Like, is it actually going to be better than that? Or as good as that even? Like that remains to be said. I mean, React Native was open sourced a year ago today. I think it was quite a year, like maybe 11 months and 2 weeks or something like that. But yeah, like at this point, when you create a React Native app, it will be more performant out of the box than beginner to intermediate level native app without you even trying. And so if you try, it's going to, you can definitely make it better, aside from a few constraints that I'll mention later, than a lot of apps. And so I'm actually working on an Android port of an iOS app right now, and it feels faster than the iOS. It's running on an Android, so I don't know. Android, like comparing my 6S to a 5X, and I guess 5X is pretty good, but still. Okay, so yeah, there's no real answer to that previous one yet. Is it like as good as a compiled language? There's a lot more to. It's not as simplistic as that, essentially. So next one comes up, some variant of this. DOM performance is good enough. DOM performance is always getting better. Do you really need to do this? One that I didn't put there is like, oh, you're killing the open web. Why do you hate the internet? And things like that. And also, like, I tried a Cordova app and it feels really fast and native. I mean, so for the first one, right, it just isn't there yet, regardless of what people are saying there. AMP is really cool, but like that's for limited use cases. Second one, it's always getting better. Is this really necessary? Just go to the first answer. It's not there yet. When it is, I think you can revisit that, whether it's necessary or not. And then the third one, like, I'm doubtful, but like, I think it's possible given the right constraints and enough effort to make a web view-based app work really nicely. But you kind of has to be like a perfect fit. So now people might ask, like, okay, so I can use these components that I showed earlier on, like all those view components, like the date picker and the switch and all that. So I can use those, but can I use like third-party native components? Like, I really want like this fancy animated GIF thing that will let me pause it and replay or whatever. So like, can you use that? And the answer to that is definitely yes. You could totally use that. Can't quite read that. So this is just a very simplistic example of some Objective-C code that you would write to bridge a view. React Native was designed with the idea of escape hatches in mind, right? There are no perfect abstractions. React Native acknowledges that, and sort of like when you need to break out of this, you can go and write some native code and then just create an interface to access that from JavaScript. So this is just like a simple map view. Don't worry about it. It's in the documentation if you want to learn more about it. And then people might ask, like, okay, can I use like the accelerometer or vibration or geolocation or camera or like push notifications? Yeah, the answer is yes. Similar sort of thing. You can create this. All those components, by the way, just ship with React Native or are available as native modules. But if there's some that for some reason wasn't included in there, I mean, there are a lot of libraries out there, so you can do something like this to wrap that and make it accessible from JavaScript. So what you would do from JavaScript here is just call like native modules dot my module dot get name, or rather say name, and that would just do what you want. There's definitely way more complicated examples than that. Again, it's in the documentation. There's a lot of libraries. Okay, so, and then another question that comes up related to these components is like, what if Apple or Google were to come out and just be like, hey, we're going to release this like new thing that's really awesome, and it's like coming out next week. When, like, how long are you going to have to wait to integrate with that? Obviously, if you were building a native app, you'd be like, oh, it's done. Now I just like write these 2 lines of code and it's in my app or whatever. And the answer to that is because of these previous slides that I was showing you. Like those don't just have to be used on third-party modules. This is the same code that's used to expose the platform modules, and so you can do things like oh, there we go, it's playing like this peek and pop. It's really easy. This is a really nice React Native app, by the way. It's called Townski or something like that. I don't know. It's Australian. I don't know how to pronounce it. All right. So okay, I've showed you like some Objective-C and some Java. So like now you're like, oh, okay. You said like writing apps in JavaScript, but you just showed me these 2 languages that are not JavaScript. So what's up with that, right? Like you can get away with not knowing it, and probably like most people who are in this room are like motivated and and smart enough to like figure out what they need to know for it. It's really, I mean, it's not so bad. I think if you're just writing like one, I mean, if you're just writing one module, you just want to expose one thing, you can figure that out. It's when you have to like architect this entire app and make everything sort of play together. That's where it becomes more complicated. But you don't really still have to know that. I mean, it's possible you'll run into cases where some native module doesn't exist yet and you need it. You could just pay like a consultant to build it for you or something.
So I was gonna say, like, I don't really know, or at least before I started going into React Native, I didn't really know iOS. I knew a little bit of iOS. I didn't really know Android. And I think the biggest thing that you probably need to know is the tooling in the dev environment to get started. Realistically, you can build a pretty complex app with just knowing JavaScript and React. Like Brent was saying, when you start to get into having to port over custom components, yeah, you're going to need to know your shit there. But in order to get up and running, there's a lot of the core stuff is already built in. And so it's really more just about the development environment and the tooling and how packages get linked. I think that's probably the biggest thing.
Yep, that is good. So another thing there is that, like you, oh, is that going to play? Oh, does it? Oh, there we go. So like theoretically, you actually don't need to even have Android Studio installed. You could just use the command line tool and run React Native, run Android, and it will just build the project for you and install it on your phone that's plugged in and open it there. So you don't have to unless you're building something complicated, essentially. And even then, it's a very limited amount that you can learn. So yeah, so how often will you be writing this bridging native code? Kind of related to this this previous one. I mean, there are a growing number of libraries to do what you need to do. There's, for like storage, you can get like SQLite libraries. There's something called Realm, which is a really good database for mobile apps. They've created their own plugin specific for React Native. There's all sorts of things, and it's growing every day. And so maybe right now, if you were to get into it, you might run into a case where there's something that you need that isn't yet implemented that you can just npm install. But I think the idea is eventually, hopefully, for most apps, you won't have to do that. So I don't think this really applies to many. Does anyone write native apps? Does anyone like ask this question to themselves? Like, yeah, okay, yeah, 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 yeah. This kind of feels like an Alcoholics Anonymous meeting, but in a pub. Native Developers Anonymous. Wrote it for 6 years. It was the worst. The shit I did, man. Okay, well, I'm going to answer it anyways, just because it's some nice stuff that I could show for you. So React Native has hot module reloading built in, so it's really slow. I couldn't figure out how to speed up the video. I'm not that good at computers. Apparently. But so what you're seeing, these little like movements that are happening, is just me saving code in my editor, and then it is downloading this new bundle and then replacing the components and applying the state to those things. And so I basically just took this fairly ugly screen and made it a little bit less ugly with hot module reloading. And this is actually like building a real app with this. This is yeah, a good app. So you also get like this inspector. So like everyone does web development here, so you're familiar with this already from Chrome. You can just like click on elements on the page and see the padding and margin and width and height, and sort of navigate through the hierarchy. You can see it highlighted, show green for the padding, etc. So you get that as well with React Native. So that's pretty nice. I think Android gives you this with something like Stetho. But as far as I know, there's nothing on iOS that does that. Another one is deployment. So you haven't made mobile apps before. You probably just heard, oh, it's so annoying to like go through the app store and like certificates and whatever. It's definitely as bad as you've heard, maybe worse. It's pretty bad. So here's an example of that app that I was just working on. After updating it, I went into, so I work with this company called Exponent. This is just this tool that we have for helping us manage development stuff. And so I just went in and pressed publish this change, and in 30 seconds, anyone who used the app had a new version of it on their phone. Well, next time they open it, at least. And then another reason why people who have been doing native development before could be interested is because of the cross-platform promise. Is this working? I think this one's not starting. Oh no, it's not what I wanted. Okay, well, just trust me that on the left side, it's doing what it's doing on the right side. So, oh no, now it's not even doing anything on either. Let's try it again. No. Oh, now okay. Should have trimmed these videos. Okay, there you go. So on the right side, I open this like Pomodoro timer thing, and I'm just like swiping around and pressing some buttons. And on the left side, it looks exactly the same, as you can see. And so yeah. There's a lot of videos there. I can show you later if you want. It definitely exists. So this kind of updating is called over-the-air updating. So what you're doing is you're sending like some script over to the client, and they are using that then to execute the application in the future. There are a lot of tools that do this. What I just showed you, like I said, was the Exponent tool that we use. Microsoft has made something called Code Push, which is really good, and it's free as well, so that's good. App Hub is another one that exists in that space, which I think was like the first one there. And then there's something called Siphon. Anyways, they're all, you can check them out. They're good. So how is that possible? So there's this is from like the developer license agreement. So the top line says an application may not download or install executable code, and then a bunch of stuff. And then the only exception to the foregoing is scripts and code downloaded and run by Apple's built-in WebKit framework or JavaScript core. So taking a step back, the way that React Native is run, right, is on the separate thread, as we mentioned before. So you still need a JavaScript engine to run. Like we're not just like, hey, go run, right? Like it doesn't make sense. You have to, like in your browser in Chrome, you'll have V8. And so here we have JavaScript core, which actually is a library that ships with iOS and that we bundled with React Native Android. And so in this case, the code runs on JavaScript core, and so we're good to go. So we can download updates and run them. Like I said, this is directly out of the license agreement, and a lot of people are doing this. Yep. Yep. Sure. I know what you mean. Okay, so the question, sure. So the question was, is the only reason why this is allowed or even possible is that we're sort of exploiting the word of the policy, and maybe the intent of the policy was very different, and the intent was that this kind of thing maybe would not be allowed. That I've, or rather than this code, some text that is grayed out in the bottom there, that says, provided that script and code do not of the application by providing with the intended and advertised purpose of the application submitted to the App Store. So I think in that case, as long as your update is just like, oh, I did a bug fix, so I added this new feature or whatever, and you're not like turning your Meetup app into like a hookup app or something. I guess it's kind of there.
Yeah, I was gonna say too that like this. So even if Apple, like, they're pretty restrictive, right? Sometimes. No, but they even if they close this loophole, right? That is sort of being exploited to some extent. The worst case is that you're doing a redeploy, right? So you're in the same boat that you're already in if you're doing native app development anyway. You just can't do those hot deploys, which is kind of nice for quick bug fixes, or like you're finding a style is all messed up. So I think it's definitely not a deterrent from going the React Native route.
All right, that was my hype man. Yeah. That Apple spends a lot of money making sure that it's not exploitable. Is what I heard. Yeah. Google. Ooh. Yeah, there you go. Yeah. Okay. You would have seen from the video that was supposed to play earlier that like you can actually share code, but I think a common question about that is like, oh, but like learn once, write anywhere. That still sounds like a lot of writing, right? Like sure, there's not much learning, but there's a lot of writing. So that's kind of it's kind of unclear. I think that slogan that people started saying when it was announced last year. For people who aren't familiar, this was sort of like a tagline. They're like, oh, instead of write once, run anywhere, or learn once, write anywhere. So that's kind of like being transitioned to React is sort of a horizontal platform. So just updating you on the marketing jargon. But I think that's maybe more clear that like it doesn't mean that you have to rewrite it on every platform. And so you end up with like questions like this, like, oh, but with like blah, 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 I can write once and run it everywhere. Why would I want to like write twice to run twice? And you're like, okay. Like, I mean, this is another like nuanced question because there's a lot of, there's a lot that it leaves out. So maybe with like WebView apps, you can write once and use it on like Windows Phone and Android and iOS. But it's not going to like look. I mean, who cares on the like Windows App Store? It's like, oh, an app, awesome. But like on the other ones, they're like, oh, this looks weird. If it if it doesn't actually like look like something intended for the platform. And so React Native, I think, has a very nice compromise on the solution. And so you can share most of the code in your app. But when you get into things that you want to customize in the platform, so if you look at the Facebook Ads Manager app, which is implemented fully in React Native on iOS and Android, there's a slight difference in that like one of them has a tab bar and the other one uses, I think, a drawer layout, which is just that sidebar that you swipe out. And so you want to change that kind of thing. Often they're like these container views or like navigation views for how you get around your app. But when you're looking at like the actual content in it, usually it's pretty much the same. So that part you can definitely share. Another thing about it is that when you require these components, you can give them certain extensions. So if you say like my special view.android.js or my special view.ios.js, depending on the platform that you're on, the correct component will be used. And so you can kind of, if you design it right, just like pretty much write once. Of course, there are places you have to write multiple times, but this is a very frequently cited number, but I'll say it again, is on the Ads Manager app, Facebook was able to get like 87% code reuse across platforms from iOS and Android. So that's pretty good, I think. I don't know why this is blank. Right. So then a lot of people will be like, oh, that sounds good. So it's just like I'm a mobile developer then, like double my salary. It's not quite that simple. I mean, there are really a lot of similarities, but I think it's better to think of React Native as like it's not Node, and it's like not the browser. It's like its own environment. It has a lot of overlap with the other two, but it does have a lot of important distinctions that you have to consider. I don't want to go into too much detail about this because I already spoke about it for like an hour at some other conference, but you can check it out on YouTube. Just look, yeah, okay, I'll post the link. So a common question again is like, can I use other JavaScript libraries from NPM? So just to set some expectations there, like I said before, it's a different environment, right? There's a lot of overlap. So you can definitely use a lot of these NPM packages, but if they depend on any of the node standard library or depend on the browser environment in any way, such as for the DOM to be there, that, yeah, or their submodules too, so that's always fun with NPM. Then they won't work. But we found that like a lot work. I mean, if you're using like Lodash, probably everyone uses Lodash here. Or maybe you're like, oh, I love Jeremy Shkinas, I should use underscore. Civid, John Dalton, whatever. But yeah, probably everyone uses Lodash because it's faster and immutable. And there's like a million libraries on there, and a lot of them will work. It's just, and if it has some like slight dependency to the DOM, you could just submit a pull request and be like, hey, remove that. So, or like add this conditional so that if this thing doesn't exist, then you do this. Or you can polyfill something. Yeah. So one area where it's probably just worth emphasis is that maybe you'll think, oh, then I can just use React components from the web. Well, like not really also, because they're kind of tied to the DOM. If you look at the components that exist, they would often do things like use divs, right? Like everyone uses divs or spans or whatever. And so you can't do that. You could polyfill the div component and use them. Like there are ways to do it. There are a lot of efforts being done to make React Native portable to web. Just kind of just remove the native and just call React as being the, as I say, the horizontal platform, but it's not quite there yet. Yeah, in summary, yes, you can use a lot of them, but not all of them. Another one is like, oh, I love Bootstrap, it's so good. Can I use it on React Native? Well, you can't use Bootstrap itself. And then people will be like, oh, but is there like an equivalent of Bootstrap for React Native? No, I think this guy's doing something like that though. But actually, you find that you don't really need it as much as you do on the web. I mean, the web, like if we remember when I like went back to the like the second slide there or whatever, where it showed the different platforms side by side. I mean, the web like just looked awful, right? That was like, this is how it looked in like 1991 or whatever, when people were like first making browsers, and these are the default styles that come out, and so you need something to bring like some sane styling by default. But you get a lot of this already with mobile operating systems, and so you don't have to be as concerned about it. Yeah. Oh my God, how much time am I taking here? Yeah, oh yeah, I can do that. Okay, so animations are another one. Like I said earlier, if you want to like remove something from the screen, like fade it out and then remove it, it's really easy with jQuery, and it has been kind of difficult up until recently with React. And so this is like a legitimate concern. Everyone, maybe you've used like React Tween State, which in the browser you're like, oh, I can kind of get away with that because it's pretty fast. But when you're like re-rendering your component constantly, it's not the best, and you have to like do a bunch of hacks to make it work okay. So what we have now are a couple of really good libraries for dealing with this. There's one called React Motion, which handles specifically the case of like mounting and unmounting components and animating those transitions. That's sort of the intended use case of it. And then there's the one that was built specifically for React Native called Animated, which is, I think it's only partially made it to the browser. I don't really do web development right now. I think it works in the browser right now, though. It's just like not totally there. So the way that this works is it's a declarative API for doing animations. And animations are really cool. I think it's worth like looking at something like D3 or this animated library and really thinking about what animations are and how they work at some point. As everyone here is like a front-end developer, it's an interesting idea, right? You have some, essentially you have some value that you want to base some other values off of. So you might say like the touch position is 200 on the screen, which translates to an opacity of like 0.67 or whatever, right? And then as you move it in, maybe it fades differently. And then you want various other components on the page to react to how that value changes. And so the way that this API was constructed was around the concept of having these animated values, which you can then interpolate other values from. So the first thing we do here is we create, here, this is just a very simple example. I'm creating an animated value, initializing it to 0, and just calling it entrance. The next thing I'm doing is attaching it to a view. I'm just going to set it as the, I'm setting it directly as the opacity. So it'll start off as being totally hidden. And then I'm taking that value, which starts as 0, and I'm interpolating it. So for the value of 0, it's going to output negative 180 degrees. And for the value of 1, it's going to output 0 degrees. And then it will just automatically calculate within that range, depending on what the animated value is set to, what the output is of that interpolation. And so I bind it to this view, and after that, when the component mounts, I just fire a spring animation on that value and say, okay, now spring to the value of 1, and then start it. And what that does is it will just fade it in and spin the view. So it's, yeah, it's pretty good for that. Like this is, like I said, very simple. I have an example on GitHub of like making like Tinder, for example, which is super easy with this API. So Tinder. So as I mentioned before, one of the issues with animations is just that it runs, at the moment they run on the JavaScript thread, right? So what you see here is like, as this is animating in, I've simulated a bunch of slowness. It was actually pretty fast, but it does happen that it can be quite slow. And so I simulated that so that you would see that it's sort of like janky and like animating in really awkwardly. And then I switched this over. I just did like a one-line change to make the animated value run on a native thread. This is with a bunch of changes to React Native. And what happens is it ends up being very smooth. And so like I was saying, an important concept with React Native is to help you kind of fall into the pit of success and to give you a lot of these optimizations, design APIs essentially in a way that they can be optimized without you having to do anything about it. And that's sort of how we're hoping to get around the animation problem. There are other ways right now that work just fine. It's not to say that like animations always look terrible right now. It's just that you have to be more careful than I would like to be. Another one that comes up, like probably, how many people have heard of Flux? How many people would be like confident to come up here and explain what Flux is right now? Like, okay, right? So it's like a thing that's like, ooh, Flux. It's so hot right now, right? But like, it's like, what is it though? It's actually like it's pretty simple. For React Native, pretty much. I mean, these days when you're hearing Flux, just like forget about Flux and just think Redux. Everyone does Redux now. It's like the evolution of where Flux is gone. Flux is just a way to say like, okay, you have your components and they have some data in them. Nope, don't do that. Put the data over here. And then when the data changes, tell the components to update. It could be a terrible explanation. I just, yeah. Anyway, look up Redux. There's a really good series on Egghead about it. It's incredible. They're like, it's such a simple way to think about organizing your application state that like if you're not even going to look at React Native, I would highly recommend just checking out Redux. You can use it on anything. If you don't use React, you can use it with Angular. And yeah, or whatever else, Ember maybe. Actually, I don't know about Ember, probably. They're porting it to like other frameworks. There's like a port of it on Swift. People just realize that like this is really a simple model for thinking about how to organize your application state. And so yeah. Another one that comes up maybe is like GraphQL and Relay. So how does that fit in here? So GraphQL and Relay, you can think of it sort of as like, you have Redux, which is like this bare bones simple thing for managing your application state. And then you have like Relay, which will like handle everything. So it'll be like, I store your application state, I handle making these requests to get your data for you, I handle caching that data, I handle like optimistically updating the data, and all sorts of things for you that you would have to do outside of that. So like Redux is just a place where you're like, oh, we're going to put this data there, and then Redux will tell everything that depends on that it needs to update. Relay is like, tell me what you want, I'll hook you up. It's sort of like your drug dealer or something like that. I don't know. No drugs in Calgary. So what if I already have an app written in Objective-C or Swift or Java? Can I still use React Native for like a screen on it or like one small thing? This is a very common question. The answer is very simple. It's yes, you can. It's quite easy. This is what Facebook is doing. Without knowing it, if you use the Facebook app, I'm sure you've used React Native at some point. It's embedded all over the place in just like small pieces. Yeah, so definitely do it. A lot of people do that. That said, there's a really smart guy named Andy Matushak who used to work on UI at Apple and like the gesture system and things like that. And so he works at Khan Academy right now, and he says about React Native is that he thinks it's a lot more compelling if you're not trying to incrementally adopt it. So if you're not trying to go like one screen at a time. And following up with that is that like the situation is that you already have. Now you have other thing, and you kind of like, I think you get all the benefits, but at the same time now you're dealing with. So it is definitely less compelling. In the case, I think it's more of a long-term. We want to make everyone able to work on everything in the front end. So yeah, if you want. Another question, like, can I use an IDE for this? Especially if you're coming from the native, because Xcode, Studio, there's all sorts of things built into an IDE that maybe you don't get normally. There's actually a lot of IDE. This is a really cool one called Deco. It's actually unreleased as a imagine it, but here's a video showing it. So what's happening is he has like the code there. Now just added a component by searching for it. You see a list of the properties on the right side, and he can just adjust those properties and see it live in simulator as he's doing it. And so in this demo, he builds like the Uber interface in 5 minutes or whatever. So it's kind of like the Rails blog in 5 minutes example. It's pretty neat. Microsoft has added React Native support to Visual Studio Code, so you can get autocomplete and whatever. Then Nuclide is the IDE sort of from Facebook, built on top of Atom. It adds a bunch of React Native specific stuff to it as well. So here he's like running the packager, which don't worry about it, it's just a thing. If you use React Native, you'll figure out what it is. And then you can like see the logs from there, also autocomplete. There's this thing called Flow, which does static type checking. It's all built into here, which helps with autocomplete as well. All sorts of cool stuff there. So yeah, there are IDEs. I mean, they're a work in progress, but there are IDEs. So yeah, now maybe people are, sorry, this is just like me rambling on and on, but I'm going to keep going. So the development environment and workflow, maybe I'm just you thinking this, but maybe you're thinking like, this sounds really great, but like, what's it actually like, right? What happens when you're using it? Like how mad do you get? How bad do things break, right? Yeah, they can break pretty bad, to be honest. Like sometimes you get pretty mad. I mean, if you're using NPM, like, I mean, how many people have an alias to like RMRF node modules, NPM? Yeah, right. It's just like stupid thing. So there's that. One of the issues is like the upgrade path isn't clear. So what happens with the releases with React Native is that actually like Facebook is always running off of math internally. So releases are, I mean, almost like a courtesy, I guess, for like the open source community. And like they don't care, right? It's like, I mean, they do it. They want these releases to because it's important for them to have, I think, this open source project that is just bigger than them. They believe in this idea, blah blah blah. But what you have is people who this is not their top priority. And then you have some people from the community as well, like myself, who like we have our own projects too, and so whoever is kind of around to write the release notes and feels like it, they can write the. If you want to write the release notes, you want to write the release notes for the next one. Okay, well you can if you want. Like anyone can do it. It doesn't really matter. You just have to read over like 500 commits and be like, what changed? I mean, people will review it and make sure it's not ridiculous, obviously. But I mean, it's a thing where this is an open source project, right? This isn't like this isn't something that someone is producing so that you can use it and then give them money to use it. They're making it because it's useful for them, and it's also useful for them to have other people contributing to it and whatnot. So the result is just that the upgrade path isn't always clear. Because they don't go through that upgrade path. They're just always like, okay, master, done. And then just trying to be like, okay, how do other people do this? I don't know. Yeah. Like I mentioned with NPM, sometimes the dependencies break. So you might have like, I mean, probably everyone uses Babel, right? And so it's like Babel, it's just like NPM install, oh, this thing is broken now. And I don't know why. And it's just like a minor version change that broke like semicolons in static properties or something like that. And it's like they didn't use semver properly that time or something. Who knows? It's a lot of stuff like that. This is taking a long time, and I still have 35 slides, so I'm just going to skip this one. So this is like using live reload with React Native, so it's pretty nice. It's not quite as good as the hot reload I was showing earlier, but what happens is that anytime a file changes, it'll just reload the app. Here I get an error screen with a very descriptive error message telling me on what line and what file the error came from, and then it will automatically reload the file again once you fix that. So that's pretty good. I'm just going to go, how do I debug my app? So you can use Chrome for debugging. Just press debug in Chrome. It'll open up Chrome debugger on your machine. You can set breakpoints. Source maps are connected. So you just do like commando, search for the file, drop a breakpoint, run in there, inspect the state, fix it, go back, have a beer. Yeah, enough of that. So crash reports. Okay, whatever. It's just use stuff. Through time. You can definitely do crash like Sentry and things like that. So a lot of people would be like, oh yeah, this sounds great, but I just looked at the docs and they're terrible. Like, again, it's like something where Facebook doesn't use the documentation, right? They have their own, like, I mean, people at Facebook, I think they just read the code. I usually just read the code. I don't really look at the documentation either. So what happens is that when the people are working on the framework don't do that, then you end up with this problem. However, everyone is very aware of this, and so here's a post on the core contributors group, which you can definitely check out on Facebook. It's open, and so Christopher Chateau mentioned, like, basically wants us to discuss like how can we make the documentation awesome. He has some really interesting ideas there. If you have ideas for how to make it better, or if you just wanted to contribute in some way, that's totally welcome also. Testing apps. This is too long of an answer. I'm going to skip that. Android is not ready yet. Is this true? Android is in a pretty good state, actually. It's not as far along as iOS. In some areas, in other areas, it's further along, sorry. So for example, like web workers are implemented on Android, but not on iOS. And so it just really depends on what ready means to you. Like, does it have something that you need or not? I guess is what matters. Lots of people are using it in production just fine. So yeah, so a lot of people, maybe a bunch of people use like parse here, and then you're like, oh no, like now I have to run my own parse server. Like, this is exactly what I didn't sign up for with parse, like literally exactly what I didn't sign up for. And so you might be wondering, will there be any long-term support for this? No, there won't. Like, that said, parse like parse was a service, right? They had to maintain these servers. They had to have these people like building this thing, making it better, whatever. React Native is a library. It's out there. You could do whatever you want with it already. Again, the ongoing or the risk associated with that is that you could kind of think of the development efforts that Facebook puts into React Native as a service. And if you look at it from that point of view, right, there's definitely some risk there. But I think the risk at this point, at least, is very low. Facebook has invested a lot into this. They have 20 plus engineers working full time on it, and they're only increasing their investment and commitment into it. So at this point, it seems like a pretty safe bet. But definitely risk. So if you have zero tolerance for risk, then stay in bed. Yeah, and definitely, like, if you're a company that requires some sort of like SLA associated with like whatever software you use, you're not going to find anyone who's going to say, we're going to get back to you within 24 hours and help you fix an issue with React Native. Like, you cannot pay people at Facebook to do this. They're already paid very well. They will just be like, I'm too busy. However, one workaround is that if you find someone who worked on React Native at Facebook before and has since left Facebook, you can definitely hire them, and I've definitely done that. So another one is like, like if you look at the repository, there's so many issues and pull requests. It says 943 issues and like 205 pull requests. That's a lot of issues, right, for GitHub. I mean, it's a big framework. There are a lot of things that go into this. I don't think there have been, obviously there's massive projects like Linux, but if you look at things like UI frameworks, I mean, there's nothing that I think is as ambitious as what React Native is proposing, where you're talking about like rebuilding this entire UI framework across these multiple platforms. It's like pretty significant. I mean, that said, like half of these are like, hey, like my thing doesn't work and stuff like that. Like, how do I press button? Yeah, and so like there's a bit of that. Okay, maybe not half. There's a lot of legitimate issues in there, but there's the risk associated with that. It's a work in progress. Lots of pull requests. Yeah, it takes time to review those. So where do I find the roadmap? And then a follow-up to that is sort of like, so like how open is this really as an open source project, right? A lot of open source projects will maybe like publish their meeting notes and that sort of thing. Like Relay has started doing that recently. That's definitely been an issue in the past with React Native, where it's been more closed than a lot of people would like. There was a big Canadian company that was hoping to really make a big bet on React Native, and they had to back out of it because they just didn't feel confident that they were able to get enough insight into sort of what the development process was and have maybe a big enough say into what was being worked on and what was being merged in. And so they've mentioned, having this, because you essentially have you have this master on GitHub, and then you have the internal repository at Facebook. And so you don't know what's going on in the internal repository at Facebook. They will sync these commits when they want to the open source repository and say, okay, this is public now, but you don't really know. And so this is something that has improved a lot in the last few months. There's been a lot, like that contributor group, I'll show you here, that's open. You can't join it because the idea is that we have a lot of the signal to noise ratio is very high. You can definitely make an argument for why you should join it. There's a forum saying, hey, I think I can contribute this and that. You can definitely join the discussions there. But a lot of the internal meeting notes are being posted to this now, as long as they don't reveal some sort of like confidential information. You can ask a lot of questions. People are very open about it. So that's quite good. Another thing with the like roadmap is the way we're kind of doing the roadmap is we have this tool called Product Panes, which was actually made by a former Facebook employee who worked on React Native. It's just a site where people can go and say, I have this pane with this product, and then other people can go and upvote it and whatever. So it's like Reddit for like annoying things about products. And so we use that for React Native actually, and it works pretty well because if we have these old issues that are just sitting there that maybe someone posted it and it's an issue that maybe affects, like, we think one person, it doesn't affect anyone looking at the issue. Like, what are we going to do about it? We can't just, if we just leave it there and ignore it, that's, I don't know, it's not maybe the best thing. And so often we'll just move these over to product panes and say, hey, we've moved this. If this interests you, upvote it here. And so there have been a few instances of things where we thought nobody really cared about it, and then we moved it over here, and we had a flurry of upvotes on it, and so actually resources were then dedicated to fixing that. So that's kind of how the roadmap for open source is determined right now, is just based off of, like, what are the biggest pains people are having with it as dictated by that. Another one is, like, related to the, like, legal license of React Native. It's definitely a lot of FUD. Like, a lot of people will, if you go on Hacker News, they'd be like, oh, check out this cool React thing. And then someone will go on and be like, well, I can't use React because then Facebook will, like, own me. And then, but it's just stupid, really, if you think about it. So here's the license for it. It's BSD. So Google uses React. Microsoft is building tools for React and making inroads to using it. Walmart uses React. Apple uses React. Netflix, Airbnb. I feel like these companies would not expose themselves to some huge degree of legal risk if that were the case. And so React Native has the same license as React. And so this isn't, I don't think that's really an issue. It's just, yeah, definitely if it is, you should have your lawyer look over it, but I don't think it is a concern. So we're getting pretty close to the end. Sorry. So has anyone actually made anything with it? There are a lot of apps made with it. You could check out the documentation and go to the showcase on the top. I'm actually amazed by the number of apps that have been built with React Native in just 1 year. The showcase, I don't know how many it has, something like 70, but that's not actually, like, all of the apps. Those are just people who went through the trouble to submit a pull request to add their app to the showcase. I know of a bunch of apps that actually aren't even on the showcase. And so here I'm just scrolling, like, this random React Native directory and opening things. The one on the right is Discord, which is used for the React community chat. Yeah, bunch of things there. Okay, this one's really short. There's unsolved problems because there's not much to say about them because they're unsolved. So React Native does not currently have good support for complex and related gestures. So an example of this is from Andy Matushak's talk from ReactConf. So if you look at the 2 points there, this is Apple Maps. If you double tap, it zooms in. If you double tap with 2 fingers, it zooms out. If you drag or rotate, it does obviously different things. There are all sorts of gestures that you can do, and React Native doesn't really support all of these in a very good way right now. You can definitely implement them. It's not going to be the cleanest, and you might just want to go into native if you're doing something like this. Another example of a very complicated gesture is one that involves multi-touch. So here in Keynote, you're, like, picking up a card, and then you're holding your finger down, and then you're dragging another card away. That's something that there needs to be work done on this. Nobody has really made, like, a very solid declarative gesture handling system like this yet. Probably the closest is iOS. Another problem is with list views. So on native, what you get is, so if you have a list of, like, 10,000 items, then you probably only actually have, of those items, maybe like 10 actually rendered in views at a given time. And what happens is, as you scroll down, it will take a view that's gone off screen, put it at the bottom of the screen, and update it to have the content of whatever is in that cell that was just scrolled into view. This is possible in React Native to an extent, but that very much goes against, like, how React works. And so there are no practical implementations that you can use today where memory usage is very good while at the same time maintaining scroll performance. So just a quick example of a list view. Like, this is just a simple list view in React. Some rows and, like, sticky headers. Another one is that scroll performance in list views can be a problem. So similarly, because you're not just taking this view, moving it, and then changing the contents. Instead, what you're doing is, like, recreating that view and all the subviews. That's a lot more work, potentially. I mean, I get there are cases where it could be more work to update everything, but generally speaking, it's more work to create this entire component and all of its subcomponents. And so what you end up is potentially situations where you're scrolling and you can't, the rendering of the rows can't quite keep up with your finger as it's scrolling. There are ways to work around this. I made this view that has like 2,000 things in it, and so this is like a pretty common UI on mobile where you can navigate through a list like this. But in order to do this, I had to do a workaround where I only rendered like the absolute minimal amount of content while you're scrolling, and then when there's idle time, using request to idle callback, do you actually render the full view. So it's just like a placeholder otherwise. So there still needs to be a lot of work done on there, on list views. Okay, 86 out of 95. Forms. So everyone everyone needs them, but there's no good general API for forms. So what I mean by that is like forms on mobile are a little bit different from on web, because you end up with cases like this where, so see, I'm typing and then I press next. Now, oh, so I pressed next already, and it didn't scroll down, so my keyboard was covering the next field, right? And so this is something that there are just a bunch of different behaviors around that. Like what's supposed to happen when you switch to the next one? Probably you want to scroll to the next thing, but do you want to like center that view on the screen? And what if the container view isn't large enough to fit so that you like scroll in? Or like I don't know, there's just all sorts of cases surrounding that, and it's not like, I say it's a hard problem only in that it's like a hard API design problem and a hard to understand all the edge case kind of thing problem. It's not like hard in the same way as list views, where it's like this is inherently a very difficult thing that could involve taking a step back. And similar to like the list views, really we're just pushing JavaScript in like different directions than it's been pushed before. In the browser, it's people have complained like that the DOM performance is slow. But that's not the issue here. The issue here is that like we're getting bottlenecked by JavaScript. And so there are a lot of potential solutions to this. There's a really great blog post by a different Andy Street, who I mentioned at the beginning, that goes, I highly recommend reading this, even if you don't use React or use React Native. If you use JavaScript, it's just interesting to see like what are the problems that you face when you use JavaScript to create such a highly interactive and demanding interface. And this goes into a lot of detail about that. And it's definitely like the direction that things are going. It talks about web workers a bit and stuff like that. Okay, certain behaviors are hard to reproduce in a reacting way. So I'll just show you this one quickly. So when you zoom in, it reuses that view. Oh, there we go. React doesn't allow you to move a view from one parent to another. It will, under the hood, actually just like delete the view and recreate it at the other parent. And so it makes it a little bit complicated to do this kind of stuff. It's definitely possible, but there's not really a good clean way for that right now. And then getting to the end, there's no reacty way to run JavaScript code in the background or when the app is closed. So like, let's say you have an alarm, you want to make an alarm app. You would have to write some native code to wake the app up and play the alarm when the time comes. That's something that can definitely be fixed. It's just, it hasn't been addressed at this point. An example of that is just like this Pomodoro thing. If I were to hide this app, the countdown would stop right away because the JavaScript thread freezes. And that's an intentional decision to save battery life. Profiling and debugging can be pretty tricky when you're going from native code to JavaScript code. Like let's say you want to step through some code and see like, okay, what happens when I do this? Okay, and then this next thing. And it's like, okay, now I hit the boundary between JavaScript and native. So I can't step into JavaScript now. So you have to set up breakpoints in these different places. So it's not always clear about that. And just similar, like you have to, like when you get into profiling, there's like quite a bit of like in-depth stuff that you have to look into. This could definitely be made, I think, simpler. There should be ways to surface performance problems in an easier way. But yeah, essentially it all boils down to, in terms of these problems, it's still really early. It's not enough existing expertise. in React Native right now. And so, you know, it's a risk that you engage in if you're getting involved in React Native. Like, it might not be possible necessarily to find someone to work with you on a project. So that said, I think a lot of people who have native experience will probably just pick it up really easily. And the only other risk aside from that is just at this point in time, there are kind of unknown performance implications in the future. What happens to iOS? What happens to Android? How does that shape React Native? I don't know. So hopefully that answered a lot of questions. It did take a lot of time, so good. Oh, there's a question. So you can to an extent. There's a library called React Native GL, which allows you to use. Oh man, I'm so bad at OpenGL. What are the two types? There's vertex shaders. Yeah. Like you can apply like shaders to videos or like random views or that kind of thing. And it's actually the exact same interface as on the web. So there's ReactJL and React Native GL made by the same guy. Yeah. I'll take your word for it. Yeah. Yeah. Yes. I believe the lowest supported version of Android is 4.2. Yeah. Whichever one has choreographer. Choreographer is a requirement, and that it's pretty heavily dependent on. I think it's 4.2. And on iOS, yeah, similarly. I mean, you could package like a JavaScript core runtime with the iOS client as well, but then you just end up with all these other problems, and you're just like, iOS 7, who cares? Yeah. Okay, thank you.
Awesome, thank you, Rat. Thanks, Brent. That was, I think, like he said, that was lengthy. Thank you for everybody else for sticking around. But I think realistically, like all this stuff is online, but this was a crash course in React Native that he just gave you, and this probably saved, if you decided to go down this route, it probably saved you like at least, if not more, of like all the shit that Corey and I have tried to figure out some of the time, and like, you know, we're even learning some stuff here too, which is great. So I think another round of applause for Brent. He was bringing a lot of this React Native Conf here, and another round of applause for Gabe as well. Really sweet presentation. So thanks guys for coming out, and everybody else next time.